Good evening, everyone. My name is Carlo Rafael Rivera, and we are Group 4 from DSI Management, and we will be discussing our group assignment number 1, which is 4.7 on the company Allen Furniture. My group is comprised of I myself, Carlo Rivera, Kyle Bonhoc, Marvin Chow, Morid Mohammed, and Joshua C. I will be discussing the problem and also the first letter of the whole problem itself. So 4.7. Allen Furniture is a manufacturer of handcrafted furniture. At the start of January, Allen employs 20 trained craftspeople. They have forecasted their labor needs over the next 12 months as shown in the following table. Each trained craft person provides 200 labor hours per month and is paid a wage of $3,000 per month. Hiring new craftspeople requires advertising, interviewing, and then training at a cost of $2,500 per hire. New hires are called apprentices for their first month. Apprentices spend their first month observing and learning. They are also paid $2,000 for the month but provide no labor. In their second month, apprentices are reclassified as trained craftspeople. The union contract allows for firing a craftsperson at the beginning of a month, but $1,500 must be given in severance pay. In any month, in severance pay. Moreover, at most 10% of the trained craftspeople can be fired in any month. Allen would like to start next year with at least 25 trained craftspeople. How many apprentices should be hired and how many craftspeople should be fired in each month to meet the labor requirements at the minimum possible cost? And so for letter A, visualize where you want to finish. What are the decisions that need to be made? What should the objective be? And what numbers will Allen acquire? And so our answer is Allen Furniture needs to determine the required number of apprentices to be hired each month. It also needs to determine the total number of craftsmen to be laid off each month. Next, the company needs to keep track of the apprentices and craftsmen that would be employed per month and the number of available labor hours. In this case, the decision variable would be the number of apprentices to be hired and the number of craftsmen to be laid off per month. The objective would be to meet the labor requirements at a minimum cost, including the hiring cost and the severance cost. That is for 4.7a, and for 4.7b, it will be discussed by Kyle Bonhoc.
For part B of the problem, here we have the condition. Suppose one apprentice is hired in January. Calculate by hand how many labor hours would be available in January and February. And we're also instructed to calculate by hand the total costs in January and February. So over here to the right, next to the problem is the list of abbreviations, with LH being labor hours, C being craftspeople, and HA being hours available. So with that is our base equation being the labor hours equal to craftspeople times hours available. So here we have 20 times 200, 20 coming from the 20 craftspeople that Allen Furniture has employed. And given the data that we have on the amount of labor hours that these craftspeople would provide, each trained craftspeople provide 200 labor hours per month, hence 20 times 200, totaling out of 4,000 labor hours available. With that, we can solve the first condition, supposing that one apprentice is hired in January. Still following our base equation, LH is equal to C times HA. You will notice that C is now 21. This is, of course, because as stated in the problem, there was a new hire in January. Following that, we reach a total of 4,200 hours available following the equation. The next condition wants us to calculate by hand the total costs for January and February. So for the first month, January, we have this set of information laid out. Cost for January includes the apprentice employment cost and the apprentice as its own variable and craftspeople as another variable with the wage present. The total equates to $64,500. And you will notice that the apprentice variable appears a second time in the equation, being multiplied by $2,000. This value comes from what the problem stated, that the apprentices are still paid $2,000 but provide no labor during their first month. Now for the second month, being February, we can see that the variables craftspeople and the wage present once again. According to the problem, in the second month, the apprentices, they are reclassified as craftspeople, which is why the original 20 has now become 21. Following the equation, the total cost for the month February equates to a total of $63,000, thus concluding the explanation for part B.
Thank you, Kyle. And now 4.7c will be discussed by Marvin Chow.
So here is the rough sketch of our spreadsheet model. All of the blocks are laid out accordingly for the data cells, changing cells. output cells, and objective cells. In this spreadsheet, it includes the craftsman wage per month, apprentice wage per month, hiring costs, severance pay, labor hours of craftsman per month, starting trained craftsman, and maximum layoffs.
Thank you, Marvin. And now our 4.7D is going to be discussed by Ward.
Now for problem D, it asks to build a working spreadsheet model for the months of January and February and asks to thoroughly test the model. Following the format of problem C, albeit only including the first 2 months of the year, we see that for each craftsperson hired or fired, they cannot be less than or equal to our maximum number of layoffs. Here we get the value of 2 by multiplying our maximum layoffs of 10% by our starting and trained craftsmen at 20. Moving forward, we see that our total apprentices are at 0. But this is only because there are no values placed within cells B17 to C17. And that if you observe that if I put a value, example 1, it changes and the rest of the spreadsheet model is affected. Now, following this, there are also total craftspeople, wherein we get the starting number of trained craftsmen and subtract it by the respective number of fired craftsmen per month. This case being B12 minus B18 for the month of January, and for the following month, the total apprentices and craftsmen at cells B23 to B24 less the fired craftsmen in February. For our available labor hours, we get our labor hours per craftsman per month at the cell B11 and multiply it by our total number of craftsmen at B24 and C24 respectively. Thus, we then get in following reference the total required numbers of 4,000 labor hours. And finally, in the table presented to the right, we have our costs and expenses for the month of January and Feb, along with their respective totals. Hiring cost is amounted by attaining the multiplying 2,500 to our apprentices hired for the month, and following that, our severance pay also follows a similar format, wherein $1,500 is multiplied by a craftsman fired for the month. Along with this, labor costs for apprentices then are gotten through multiplying our apprentice wage for the month at $2,000 to our total number of apprentices for that month. And finally, a similar format will also follow with regards to labor costs of trained craftsmen, with regards leaving us an initial amount of $60,000, which if we take note, all these values are bound to change if we put values in the cells labeled in yellow. As we see here, we can put any amount of number of people and the total will change.
Thank you, Ward. And now we will stop our screen sharing for the share spreadsheet model, and we will use an actual Excel application in order to show problem E, which will be discussed by Joshua. So hold on a second. And all right. Okay, Joshua, the floor is for you.
Okay. For problem E, the formula for maximum layoffs is starting trained craftsman which is 20 multiplied to maximum layoffs, which is 0.1. Total apprentice equates to the apprentice hired of that month. Total craftsman is starting trained craftsman, which is 20 subtracted to the craftsman fired. Total labor hours is total craftsman multiplied by labor hours per craftsman per month. These are the required labor hours of the different months, which is 4,000, 4,000, and 4,200, and so on. The formula for labor cost for trainees is apprentice hired multiplied by apprentice wage per month. Formula for labor cost for trained workforce is total craftsman multiplied by craftsman wage per month. formula for hiring cost is apprentice hired multiplied by hiring cost. Formula for severance pay is craftsman fired multiplied by labor hours per craftsman per month. And the total cost will be the sum of the labor costs for trainees and the trained workforce, hiring costs, and severance pay. And for the solver, for the set objective, the set objective will be the sum of the profit overall for 12 months, which should be set at a minimum. And for the changing variable cells are the apprentice hired and the craftsman fired. And for the constraints, the constraints should be apprentice hired less than or equal to the maximum layoffs, labor hours available greater than or equal to the required labor hours, and total craftsman greater than or equal to maximum craftsman to the start of the next year, which is 25. The total apprentice hired and craftsman fired must be equated to integers. And lastly is to make sure that the non-negative is checked and also in simplex LP and solve it, and you'll get the answer $814,500.
Thank you, Joshua. See, and that concludes our answer for question 4.7, and that concludes our video recording for group assignment number 1. Thank you very much.